Today we're going to talk about NMAP and a little bit about Wireshark. All right, NMAP is a tool for scanning the network to see what is up on the network, what ports are open, potentially what vulnerabilities or operating system are on it. It can also grab the banners of the ports that are open. So we'll just give a couple of quick little demos here with the tool. So right here, we're going to put the command in, and this is going to do basically a scan to see what is on the network, a ping sweep, so to speak. And it just takes a second, and it swept all 254 IP addresses on that network, and this is what it came back with. And it's telling you that each one are up. There's several virtual machines, and of course, parallels running on my host Mac, which will look like the DNS server and things like that. So with that ping sweep, you can see exactly what is up on the network. So you can take it a little bit further, and let's do a TCP connection. That ping sweep literally did nothing but a ping to each of the addresses on that network and see if it answered. That's a little noisy, and if ping's turned off, you may not be able to find anything out, and some routers will block that. So this is what we're going to do here is a TCP connect scan, and we're going to look at ports 53, 80, and 443 on TCP across the same network. So if we hit enter there, it'll take it a little bit to do it, depending on how many ports you ask for, but then you can see, starting at the top up here, this is for the actual parallel server, and it operates as a router. So here you can see port 53 is open for the domain controller, but 80 and 443 are closed, and then everything's closed on the other devices. And we have a Windows device, an Ubuntu device, and a Kali device. So TCP Connect, being that it's doing a full TCP handshake, it's doing a send, getting a send ACK back, and then sending another ACK. That generates a lot of traffic on the network compared to just a ping sweep. And of course, it's a little noisy. But you can do that same thing in a stealth manner, where it basically just does a send, and then when the send ACK comes back, it just resets it. So let's see here. And you can see this one, we're still looking at the same ports, 5380 and 443 on the same network. The only difference is we changed the option to a -s, capital S. And let's see, this one's a lot more stealthy, and basically just says, hey, let's talk. And when it says, okay, let's talk, then it's like, changed my mind. Talk to you later. Now that is pretty good if you're trying to stay hidden. But sometimes you may have to determine what is out there and dig a little deeper. So one of the scans you can do is an operating system guess. Basically, it'll scan the host on the network, and then based on how they respond, what ports are open, things like that, it'll come back and try to guess the operating system, and it's pretty accurate for the most part. And this one, there's only a handful of hosts on here, so it shouldn't take that long. But NMAP's a pretty powerful tool, and there's a lot of options you have in there. All right, so it finished up, and if we scroll back to the top, you can see that it's guessing right here. That this is the Parallels virtual machine that's acting like the router. So it's probably doesn't really have a whole lot of ideas to what that is, but it does say that 53 is open. All right, this other one here, if you look at this, it's got 2968, 5,000, and 7,000 open. And it's looking at the MAC address. And it's saying that it's running Mac OS 11.x, 12.x, or 13.x. And it's pretty much guessed it. That's the actual host that everything is running on. All right, so then the next one it looked at, come back with port 135, 139, 445, which pretty much means it's a Windows machine. And it did get it right. So, and then these other two, the Ubuntu machine and the Kali Linux machine, it really didn't guess those. It just kind of, it's got this in the host name because it did a reverse lookup on it. But that's pretty handy, because then you can go out and see what's happening, or what you could possibly do with each of those machines. Now, if you do a dash capital A with this, it does kind of the same thing, except it will also try to guess the protocols. You'll look at the banners on what's open, and it will also do a trace route to it. Now, that trace route won't look like much on this network because it's basically 0 to 1 hop, just depending on which one it is. So, but it will at least show you what it does, and it does take just a little bit longer than the other ones, but it's pretty cool. And then after that, I have another demo that will show NMAP doing a scan, but with a decoy. So it'll actually send out some decoy traffic, and we'll see that in Wireshark here in a second, as soon as this finishes. Okay, now that it's finished, we can take a look at this. All right, you can see the first IP address, and it has tried to guess, but it's not coming out too good with it. It guesses it's a Fortinet firewall, which it's not. It does show that port 53 is open, though, and it's Cloudflare's public DNS, and it gives you the MAC address and says it's parallels, which is good. So, and if you do a trace route to it, it's 1 hop away. All right, so here's the second one, 10.211.55.2, which is the local machine that's hosting all this. So this is the actual MacBook Pro. And you can see where it grabbed the banners and fingerprints, and it did pretty good on all the ports that were open. And then down here, it's like it sees, that gets the fingerprint for that service. And it says, that it's running Mac OS, of the current version. And it traced route 1 hop. Then we got the Windows machine, which, same basic thing. You come down here, it's 1 hop. And then we got the Kali and the Ubuntu device. Now, the next one I want to show you, let me get this going first. We're going to go ahead and do a capture. And we're going to do not broadcast and not multicast. So we're putting a capture filter in, and we'll hit start. Continue without saving. All right, then we'll pop back over here. And what I'm going to do is I'm going to do that first scan that we did, just, the connect scan. Hang on a second. And what this is going to do is it's going to show you the traffic in the background. Okay, so if we hit it, you'll see the traffic back here. And you're going to see the TCP sends, and then, you'll see the Synax probably up here. And then you're getting the resets. So there's a Synac. But you can see it's all coming from the same machine. Okay, 55.4, which is the Kali machine that we're running this on. So when it got done here, you can see it had found 5 hosts up out of 256 IP addresses it scanned. And if we scroll back, you're going to see all the traffic up in here. So you see the sends, syntax, and then the resets. So you're seeing it all. But the key thing to note is it's all from this one host right here. Now, if we swap this around, and we'll just leave Wireshark running for a moment, and then we do the exact same scan, but with a decoy set. If you pop down here and we paste it in, you can see where we're doing NMAP, and this time we're doing a stealth scan, sorry, but we're using -D, and here is the IP that we're using for the decoy, 10.1.2.3. So let's hit that. If we pop back up here, you'll see that address popping in here and there. Let me see if I'll make this a little bit bigger. So you're seeing a lot of resets to it there. Now you can put multiple decoys in, and then that would just, kind of throw people off, hopefully, where they couldn't find the actual real one that you're going from. That's the intent. But go ahead and stop this while we get up here to here. Yeah, you can see some more. You can see the normal traffic from 55.4, and then you see right by it the decoy traffic. And what it's doing is it's actually making it respond. So here we can scroll down through the resets, and you'll eventually see a reset being sent back to 10.1.2.3 from the hosts that are scanning it. So it's effective, but it's just up to you if you're going to use it or not. Typically I would use something very stealthy and just try to do it low, set the speed to where it's kind of slow, and that would keep you under the radar basically. All right, so that is NMAP and a little bit of Wireshark. We'll do another one with Wireshark and go over all the capture filters and display filters. It actually makes it a lot easier to use when you can filter out some of that traffic. All right, hope you guys enjoyed it and learned something. And, if you want something particular, throw it in the comments and I'll see if I can make a video for it. Later.